Hi there. This is the second video in a series of videos about propagating uncertainties, how to deal with what we don't know in an IB lab. Now, in the first video, we took a look at how to find the uncertainty of a sum of items, and we also found the uncertainty of an average of items. In this video, we're going to take a look at how to find uncertainties when we're multiplying and when we're squaring or cubing or something, a number. So I'm going to make another column here. We're going to call this velocity. Now, of course, we know velocity, it's a simple equation for velocity, is distance over time. So we'll go ahead and just simply take our distance divided by our time. Remember, these numbers don't really represent anything special. I just sort of made them up. So I want to find the velocity, and of course that equals the distance divided by the time. I'm going to use the average time in this case. And I'll go ahead and drag that down, and we get some very large numbers, as you can see. Now, our job, we need to take these numbers, and we need to find out how sure are we of these numbers. Now, from the data booklet, we find this equation. This equation tells us that the uncertainty of y divided by y is equal to the uncertainty of a divided by a, plus the uncertainty of b divided by b, plus the uncertainty of c divided by c. This is for any equation when we are either multiplying or dividing. In this case, we're dividing. So what we're going to have to do is we're going to have to rearrange the equation. We're going to rearrange this equation to this. Our goal was to find the uncertainty of our velocity. It's our y value in this case. So we're going to take the uncertainty of y is equal to the velocity multiplied by the uncertainty of the distance divided by distance, plus the uncertainty of the time divided by time. Now, to do this, we're going to, again, add the uncertainties above. That's just going to help us out a little bit. And I'm going to start an equation. So remember our equation. We want to first take the velocity multiplied by, and I'll open a parenthesis here. I'm going to take the uncertainty of the distance divided by the distance. And I'm going to add the uncertainty of the time. In this case, we're going to use that average time uncertainty we already found, divided by the time. Now, as you can imagine, when I drag this down, we're going to have some issues. I want to freeze the E1 and the H1 cell. So when I propagate this formula down, it's going to have some issues. So I'm going to put some dollar signs here to keep the ones in place. Therefore, when we drag this down, you see that even in this last cell, we're still referencing that E1 and H1 cell. Now, as you can see here, if I look at my uncertainties, I would say 0.2 probably is a good uncertainty for the velocity. So I'm just going to copy and paste because I'm lazy. Do a delta V is equal to 0.2 meters per second. That means that we need to round these to the 10th place to make sure they match their uncertainty. So format number will go to 1 decimal place. And we see that those are our velocities. Now, we know many more numbers than 1.0, 1.3, but we're only certain about these numbers to 2/10 of a meter per second. And so this is the limit of our what we're able to do. Now, let's imagine that we want to take these times and we want to square the times, or we want to cube them, or whatever. Again, this isn't any particular lab I'm thinking of. We're just playing with some numbers right now. So I want to go ahead and say this is going to be times squared. Of course, the units of times squared are seconds squared. By the way, in Excel, you cannot do superscripts or subscripts, but when you paste this into Word, you can. So leave this now, but when you actually plug this into actual report, I would go back and change this to a S with a superscript 2. It just looks a little neater. Now, time squared, I'll say equal average time, and I'll square that value. And we get some big long numbers there. Now, unfortunately, in the 2009 standards, there's no equation for dealing with uncertainties with squaring or finding exponents of some sort. Thankfully, in the new standards, there is. I'll go ahead and put that on the screen, and you can see it's simply the exponent. In this case, it's a 2 multiplied by the uncertainty of time divided by time itself. So what we're going to do to find the uncertainty is I'm going to say equals. I'll multiply by our times squared value and multiply that by the uncertainty times, 2 times the uncertainty divided by the actual time. Again, I want to freeze cell 1, so let's hold that as a $sign and drag this down. Oops. There we go. And so I can look at these numbers and I can see that the biggest uncertainty I have is indeed a 0.02, value 0.02. So I'm going to go ahead and use that as my uncertainty. Again, I always just pick the largest. Later you may do some of these and you may find some other techniques, but for now this is fine. So that's seconds squared. Now, of course, we need to round these all, so I'll go ahead and format cells, and we'll round these to 2 decimal places. Yikes, not 12, or 16, or whatever that was. So, okay, and now we have the times squared. The uncertainty of times squared is 0.02 seconds squared, and here are our numbers. So this is how to propagate uncertainties when multiplying or squaring something or cubing something or whatever. In the next video, we're going to take a look at what to do when we graph our numbers and we find that they don't end up being perfectly straight like we'd want them to.